Hello and welcome to the fourth lesson in the first phase of our training. So let's quickly look at the course outline for this particular lesson. That is lesson 4. In the course outline, first of all, we're going to talk of algorithms, which we've already talked about in the previous lesson. That is lesson 3. But we are going to stress more on it here because it is one of the key components in programming, as we've already stated in our previous lesson. Then after that, we're going to deal with a concept called pseudocode, where after writing our algorithms, we can put them in pseudocode. From there, we can go ahead and look at flowcharts. And then from there, finally, we look at the types of errors we do encounter during programming. So basically, this is what we have for this lesson. Now let's look at the lesson objectives. So by the end of the lesson, learners will be able to, 1, explain the concept of pseudocode. 2, specify their algorithms in pseudocode. Whatever algorithm you write, we'll specify it in pseudocode. Then from there, we go ahead and then learners should be able to explain the concept of what flowchart and be able to specify their algorithms also in flowchart. And finally, learners will be able to identify the various types of errors in programming with examples. So these are the objectives for this particular lesson. Now, here we are once again with the word algorithm, or with the term algorithm, which we've talked about in our previous lesson. Like I said, we're going to talk more of it here because it is very important. An algorithm is a sequence of steps for solving a specific problem, giving it input, data, and the expected output. So algorithm, just as we've already stated, if you thought of doing something, maybe writing a program, first of all, you just have to write the steps down and follow the steps. That is what will help you achieve success in writing or developing your program or whatsoever software you would like to develop as a developer. So the sequence of steps you write and follow is what we term as what algorithm. Can also be described as what step-by-step problem-solving process in which a solution is arrived at in a finite amount of time. It's just the same story we're talking about. The sequence of steps you write to follow to solve a particular problem. In writing a program, our intention is, in writing a program or developing a software, the intention is for the software to solve a specific problem. So writing an algorithm and then following it to solve this particular problem is what we are talking about here. Or writing the steps which you follow to solve this particular problem or specific problem is what we term as what algorithms. When we write a computer program, we are generally implementing a method that has been devised previously to solve some problem. So basically, when we are writing a computer program, in one way or the other, our intention is to solve a particular problem with it. Basically, that is what we are talking about here. So let's proceed. Now let's look at, this is a typical example of algorithm. We've already seen it before. So this algorithm is for a music purchase program. So if you're a developer and then maybe a music company employs you to maybe write a simple program for them that will help calculate and display the result of the number of music's purchase, the customer's purchase or buy. So this is just a simple algorithm for that. First of all, you need to take some inputs where you prompt your users to enter the number of songs. So the user buys like 10 songs, they enter that. So that will be the first instruction or the first step. Then after that, you calculate the number of songs. So you use the formula. Maybe the price per song is 0.99. So you use this formula, 0.99 times the number of songs, and then display the results. So it's a very simple program. So this is the algorithm for this particular program. First of all, you prompt the user to enter the number of songs they bought. Then you go ahead and take it and then process it here by calculating. That is by multiplying the amounts per the number of songs and then display the results for them to see and then do the payment. So basically, this is one of the simplest algorithms we're talking about here. Now, say once an algorithm is designed, it must be expressed or specified. After writing your algorithm, we have several ways by which we can express or specify our algorithms. The algorithms can be expressed in one of these ways. That is words. You can just write your algorithm in just words, maybe step by step. Or pseudocode, which we'll be looking at, and then try to understand what pseudocode is and then how to write pseudocodes. We can equally express our algorithm in what? Flowcharts. So we'll also see how that unfolds for us. And finally, programming language, which depends upon the programming language you are good at. You choose it and then specify your algorithm. Use your algorithm to write maybe to write a software or a program to solve a particular problem using that particular language or the language you are good at. Basically, that is that. Now, the operations used to construct algorithms belong to one of three categories. Normally, the operations we use to construct our algorithms belong to one of these three categories, depending upon the type of program you are writing. There are some programs that you don't need decision making. They are just straightforward. And there are some programs you need to, at a point in time, you will have to stop at a point in time and make decision. That is also another category. And there are some too that involves what? Repeating a process until a condition is met. That is also another category. So let's look at the one after the other. Please, excuse me. Thank you. The first one is the sequential operations. The first one is the sequential operations. So this carry out a single well-defined task. When that task is finished, the algorithm moves on to the next operation. This involves a very simple program, just as we saw in the previous, in the program for the music company. So this is one of them. This is a typical example of what? The sequential operations. It's in sequence. There is no decision making anywhere. So once the user enters the number of songs, it takes that as input and then go ahead and process by calculating and then displaying the results. So it's a very straightforward. There is no decision making at any point. So this is one of the sequential. There's straightforward. One of the typical example of what? The sequential or the sequence operation. So the moment the first line is completed, it moves to the second line and do that, moves to the third line and do that, and then the program ends. So that is that. Depending upon the number of lines, it will just follow in that order until it gets to the last line and then the program ends over there. Now we have another category. That is what? Conditional or decision or selection operations. These involves decision making at a point in time. So, for example, we are using the same music purchase program again. Let's say with this music purchase program, we'll have to make a decision at a point in time. So we say enter the number of songs. So after entering the number of songs, all we are going to say is maybe we would want to give discount based on the number of songs the user or maybe the customer buys. So we say if a customer buys more than 10 number of songs, then there should be some discount. Are you getting it? So we have to make decision here in this particular program. So let's see how that unfolds. So we see that after taking the number of songs, we make a decision here in the second line. So we say if the number of songs is what? Greater or equal to, because we say if it is, okay, we say it's more than 10, right? If we say, so we can say that if the number of songs is greater than 10, then we would like to what? Subtract a percentage from the total amount the person or the customer will be paying. So you can see that we are making a decision here. So that is a typical example of what? Conditional or decision or selection operation. In the flow of the program, at a point in time, the program stands and make a decision. So say this ask a question, and the next operation is selected on the basis of the answer to that question. We'll be seeing series of examples as we proceed. So let's go on. The third category is what? Iterative or the loop or repetitions. This involves repeating the process. So they tell us not to go onto the next instruction or the next line, but instead go back and repeat the execution of a previous block of what? Instruction. This particular category falls under maybe when we develop games. So we set some number of lives, right? So as you play, your lives will be reducing. So during this process, iterative or maybe looping is taking place here. when you are caught the first time, before your life will be reduced by 1, it will loop through and check the conditions. And then it will give you another chance to what? Keep playing again. So you are repeating the play. Then when you are caught a second time, then it will loop through and check. If you still have lives, then it will come back again. It has given you another chance to what? Repeat the process. That is, repeat playing again. So it will keep doing that until maybe the game is over. Maybe a condition is met. And which condition is that? Maybe a condition which is said that when something happens, then stop the game and tell the user that the game is over. So that is another typical example of that. Let's see the examples here. So this is an example of a sequential operation, which is just in a sequence, just straightforward. So we are explaining it very well here once again. A sequential operation consists of series of consecutive statements executed in the order in which they appear. So it's just straightforward. There is no curve and no bend anywhere. None of the statement in this operation causes a branch. So the general form of what a sequential structure is as follows. This is one of the examples of what sequential operations. So enter first number, enter second number, then you go ahead and calculate the sum by what? Adding the first number to what? The second number, and you display the results. So you are done. So it's just a straightforward. So there is no curve, no bend anywhere, no decision making here. So in a program where we don't have decision to make, the program runs after the first line, it comes to the second line. We've already talked about how programs are executed, and we say they are executed what? Line by line. After this line, they need to go ahead and execute this line, and this one, and then this one. So a program which has free flow of what? Execution of the lines is what we term as what? The sequential operation. It's in sequence. After the first line, the second line is executed, the third line is executed, and then the fourth line. There is no repetition, there is no decision, and there is no question, and there is no anything anywhere. It's just straightforward. So this is a typical example of what? Sequential operation. You can think of writing a simple program like that. So that is one of the examples of what? Sequential operation. Now let's look at the conditional operation. Selection, decision, or conditional operations contain branch, point, or statement that cause a branch to take place. So with the conditional operations, when the program is flowing or is running at a point in time, it has to stop and make decision based on the conditions given to it. Let's go ahead. In the conditional operation, there is a branch forward at some point which causes a portion of the program to be skipped. So when we set condition, depending upon the condition, every condition with what? A block of code that follows it, which should be executed when that condition is met. What I'm saying here, we'll see it in example. So in every condition, there is a block of code under it. When that condition is met, that block of code will be executed, and the rest of the conditions will be skipped. If that is not met, it will go ahead and check until a particular condition in the rest of the conditions, until one of them is met. Then it will go ahead and execute the block under that one and skip the rest. So this is a typical example of what? Conditional operation. So depending upon a given condition at a branch point, a certain block of statement will be executed while another is skipped. Depending upon the condition that is set, a particular block will be executed and then the rest will be skipped. Let's check the example. This is a typical example of what? Conditional structure. So this is a very simple program where we try to say to someone if the person is a Ghanaian, or maybe yes, would like to take input from the user, that is the person's country of birth. Then we make decision with it. So it's a very simple program which tells the person whether he or she is a Ghanaian or not. So this is how the program flows. So the first line is a straightforward one. So enter your name. So the user enters the name. So after entering your name, enter country of birth. Where you are born, you enter that. If country equal, this is what a comparison operator, right? If country equal Ghana, what this line of code means is that if the country the person comes from is Ghana, the program should display and tell the person that he or she is a Ghanaian. So you see that at this point in time, it will make decision here. Else, display he is not a Ghanaian. Else means if the country we enter is not Ghana, it means the person is not a Ghanaian. For that matter, the program should go ahead and display what? He is not a Ghanaian. Now, we stated something when we're explaining this. We say what? Depending upon a given condition at a branch point, a certain block of statement will be executed while another is skipped. Let's go back and see the one that is executed and the one which is skipped and the conditions there. Now, let me just take myself as an example. My name is King Solomon, maybe Rashid. I've entered that. The country of origin is maybe Togo. So it's going to make decision here, depending upon what I've entered. If the country is equal to Ghana, it should display to me that I'm what, a Ghanaian. But then when I enter Togo, it means the country is not what, Ghana. So it will skip this line of code and tell me, hey, I'm not a Ghanaian. So you see that since I'm not from Ghana, this block of code is what, skipped. So it will jump this one because the condition here is not met. I'm not a Ghanaian. So it will skip this line and then go ahead and then execute this one and tell me directly, hey, Rashid, you are not Ghanaian. Let's see if I'm a Ghanaian. I've entered my name. I've entered the country of birth, which is Ghana. So it will just check. What have I entered? The country, is it Ghana? If the country equal Ghana, it will skip this one. It will even come here. It will just go straight forward and tell me that, Rashid, hey, you are a Ghanaian because the country is what? Ghana. So it will always skip this one. It wouldn't even come here again. It will just execute this block. But if the country here is not Ghana, if the country I've entered is not Ghana, it will skip this one because this one will only be executed if the country is what? Ghana. If the country here is not Ghana, this will be skipped and then directly you should tell me that I'm not a Ghanaian. So that is how this is another simple program and then a typical example of what? Conditional structure. So as we proceed, when we begin writing our own programs, we'll see the categories under which a particular program falls. So when writing your own program, you can sit down and say, this particular program I'll be writing, it's not going to be a sequential because at a point in time, I'll have to make what? A decision. So that particular program becomes what? A conditional structure or conditional structured program. At a point in time, you have to stop and make decision. So that is that. Let's look at the iterative or the loop or the repetition operation. So an iterative operation contains a branch which results in a block of statement that can be executed many times. So let's take note of something here. A block of code can be executed many times depending upon the condition. It will be repeated as long as a given condition within the loop structure causes the branch to be taken. That's what I'm saying. The repetition will keep going on based on a particular condition. See, the ability to repeat the same action over and over is the most basic requirement in programming. The ability for you to write a program and then the user does something over and over and over. The program gives the user the chance to keep doing the same thing over and over. It's one of what? Basic requirement in programming. So let's check how that happened. This is another simple program for like a guessing game. So we write a simple program and say, guess the age of your friend. So this is a program which involves what? Repetition of a process. Because you can't guess once and no, right? If you guess one and no, the program will terminate and then you are good to go. There is no problem with that. But what assurance do you have that your user can only guess once and then the person will be good to go? So since you are not sure of that, there must be a block of code that will be executed for some number of times. If the user enters the first chance and it didn't work, the user must get another chance to what? Guess again, depending upon the number of times you give the user to what? Guess. So let's check that. So the program below prompts the user to guess the age of a friend. So enter number. So it means enter number, that is the age. Enter the age of your friend. Guess. While the number is not equal to the age, if the number you enter here is not equal to the age of your friend, then it will prompt you to what? Enter number again. So have you seen it? Until you enter the right number, that is when the program will jump out and then display, bravo, you have won. But then, if you fail to what? Maybe if you're unable to guess the number correctly, so the first one, say enter number. So there's a branch here, right? There's a condition here. As long as the number, while here, that is a while loop. We'll be looking at the loops. That is in the next lesson. We'll be looking at loops, so we understand better that way. While number, as long as the number you've entered here, or the age you've entered here is not equal to, this means not equal to in programming, right? It's not equal to the age of your friend. Enter number, it means guess again. Guess another number again. So you keep doing that. So you see that repetition will be taking place here. So this is another clear example of what? Repetition operation. So we'll be writing a game and you see how that works. Now here we go. We're going to look at the concept of pseudocode. Now, what is a pseudocode? Pseudocode uses short English-like phrases to describe the outline of a program. So a pseudocode is just normal English language where we use to write the steps, how we want our program to flow, or how we are going to follow and then write or how the program should be executed. So we write that in English language, just in a language or any language of your choice. So that is how it is. It's not particularly a programming language at all. No, it should be any language at all. If you're a French speaker, you write in French. English speaker, you write in French. German speaker, you write in German or whatever. So that is pseudocode. You see, pseudocode uses short English-like, normal language phrases to describe the outline of a program, how you want the program to be. It is not actual code from any specific programming language. It is not a programming language, right? It's just a normal language. But sometimes it strongly resembles the actual code. This is because if you write a pseudocode very well and someone sees it, another programmer sees it, the person can just look at the pseudocode and then the person will use a different programming language to implement the pseudocode in a programming language, and then it will work perfectly without any issue. So that is what we are talking about here. It's a semi-formal English-like language with limited vocabulary that can be used to design or describe algorithms. So after writing your algorithm, you can put it in a pseudocode form so that you can then follow it. So after putting it in a pseudocode form, that is where you see the flow of your program, where you have to make decision, you state that. So we'll be seeing an example and then series of examples of how pseudocodes are drafted or are written. That is, it's a text-based algorithmic detailed design tool. It's a text-based. We just write it, just normal English language. Let's see how that happens. So this is one of the examples of pseudocode. Say one of the ways pseudocode is useful. So let's look at how it is useful. Importance of pseudocode. First, or the first one, it improves readability of any approach, since it's written in any language. Anybody at all can read it and then try to understand what it entails. It acts as a bridge between the program and the algorithm or flowchart. Acting as a bridge between the program is just like if the program is not yet written, the pseudocode can be termed as a program because it's just a copy of the program, what you are going to be writing. So if the flowchart is not there, or the program itself is not yet ready, the pseudocode can be in place of this. So anybody at all can follow it and then use it to draw a flowchart or implement it in any programming language. It makes coding easier since each line of code is explained. It makes any programmer to be able to follow it and write codes using any programming language easier because each and every line of code is already explained. It's in a language that everybody understands. So determining errors in pseudocode is easier than in the development stage. When detecting errors in pseudocode is just simple because it's just a normal language, right? You can see where there's a problem, where the problem is, and then you solve it. Rather than it's easier to do that in pseudocode than in the programming language itself. So that is how useful the pseudocode is. So let's see. This is one of the examples of pseudocode. Say pseudocode for cooking rice might look like this. So let's see how pseudocode is written. This is just a pseudocode for cooking rice, like a sequence of steps for cooking rice. Step 1 says starts. So every program has a starting point and then has ending point, right? So you start it. So the first thing when writing pseudocode is what? To start a program. It's just like a program. So you start it. And then when you get to the last, line, you end it too, just as we see here. You start and then we end. So just like how any program is, every program has a starting point and an end point. So this is it's almost the same as your real program you're going to write. So when explaining this to your student, maybe they have an algorithm in mind. They can put the algorithm in a pseudocode like this. So it becomes a program in one way or the other. Any person at all can follow this and then implement the same thing, be it in a language or in the way it is written. You can understand it and use it as you wish. So you first of all have to start. And after starting, you do what? You wash the rice. After washing the rice, you put it in a boiling water or in a saucepan. After that, you leave it to boil for some minutes until thoroughly cooked. Then that ends it. It means the rice is what? Cooked. So anyone at all can follow this. So this is just a simple program. So when the program starts, It washes the rice. It will then pour the rice into what? Boiling water in a saucepan. It will then leave it for some number of minutes until it's cooked, and then it ends. It means your food is ready. Come and take your food. It can be a program. So this is a typical example of what? Pseudocode for cooking rice. So what will be the pseudocode for cooking yam? State it for me to see. So that is one of the examples of pseudocode. So like I said, since we have our students in mind and we are doing this for them, pseudocode is one of the key components in the computing curriculum. We are asked to explain to them the concept of pseudocode, right? So explain to them, pseudocode is just, it's not a programming language. It is just a way of what implementing your algorithm. It's written in a normal language, in a sense that it can be in English, any language you understand, you can write your pseudocode, but it has some basic principles you have to follow. Since it is just acting like a program that you have in mind to write, since every program has starting and then has endpoint, before you start your pseudocode, you must have a starting point. So you start it. So the first step is what? Start. Then the second step, what do you intend to do? So you state that. Third step, what do you intend to do after the first step? You state that. And then the third step here, what you intend to do after the second step, you state that. And then when you get to the end, the final step, then you end it. So it's just like a program. So let's look at if there's another example here. Example 2. Pseudocode for adding two numbers might also look like this. This is another example of pseudocode for adding two numbers. So you can ask a student after this to also write pseudocode for what? Subtracting two numbers. Let's see how that happens for adding two numbers. As usual, first step is always the start. So second step, you prompt the user to what? For the first number, the user should enter the first number. Prompt for the first number. So you enter the first number. Prompt for the second number. You prompt them to enter the second number. Then after that, calculate the sum of the two numbers. That is number 1 plus number 2. Then you display the results. Then the program ends. So that is that. You see that it's very straightforward. No curve, no bend anywhere. And it's just a normal language. So this is another example of pseudocode for adding two numbers. So that is that. See, it's very simple. So you can prompt your student to also what? Write a pseudocode for what? Subtracting or multiplying two numbers. Also follow the same steps and then they write pseudocode. After that, they then understand what pseudocode is and they can also write pseudocode. So that is that. So let's look at the do's of pseudocode. Maybe the principles we have to follow when writing pseudocode. Each statement should be on a new line. So you don't write it like English essay where you have plenty things and then paragraphs and all that. Each and every statement should be in a new line. So use control structure such as if else. If there is a decision at a point in time, we use this particular statement to do that. If you want to do something, maybe something must happen, else something must happen. We'll see all this when we are coming to make decisions in our program. We are going to be writing programs in pseudocode which involves decisions making. So you see us using if and then else if and then if else if and all that. We'll see that. So use a proper naming convention. A proper naming convention here in a way that user-friendly words. So use that. For example, let's talk of sum. So sum like this, everyone knows that is addition of what? Two numbers. Product, multiplication of what? Numbers. Division and all that. So that's what we are talking about here. Indentations and the white space should not be ignored. Indentation means when writing a program, you have to indent your program. So after writing these steps, say, let's assume we want to make a decision here. So we say if something happens here, if we want a block of code to be executed, that block of code should be indented. Like it should be like a paragraph. It should come and start from somewhere here. Then it's executed. Then another decision condition is here. Then the block of code should also be executed here. That is what we mean by indentation. We'll see indentation as we move on. You see a very nice program being indented, and then we see how we can practice all that when writing our pseudocode. It's very important. It makes your program look nice and readable. So keep it simple. You just have to keep it simple and then concise. Just straightforward. Not easy, not lengthy things. It should just be straightforward, just as we saw previously. Start, prompt for the first number. Not you. I'll then ask the user to enter the first number, and then I'll take the first number, and then I'll put it. No. It's not like that. It should be very straightforward. Prompt for first number. Enter the first number. Prompt for the second number. Enter the second number. Very straight, precise, all that. So that is that. These are the don'ts. Avoid ambiguity. What is ambiguity here? maybe sentences or maybe phrases or words that have more than one meaning. So what meaning are you intending to convey? So you should avoid ambiguity. The word should be clear, concise. So everybody should be able to follow it and do whatever they want with your program written in pseudocode. So this is another example here. So example 1, write an algorithm in pseudocode to find the profit on an item bought in a shop, right? To find a profit on an item bought in a shop. So let's see how the solution is. So an algorithm in pseudocode to find a profit on an item bought in a shop. So first, start. So first of all, start our program. So since we'll be taking some input from the users, such as the selling price and cost price, and these are what do you call it? Amount of money, right? So we can declare them as what? Floats. We talk of what? Floating point numbers, because at a point in time, when dealing with currency like this, at a point in time, we do have floating numbers. Like once in 50 pesos, you can see that we have 1.50. So that is why I'm declaring that as what? Float. So we use this declare to what? Declare our variables. So we say declare selling price is one variable, and then cost price is also another variable. So we are declaring them as what? Floats. So that is that. You know what I'm talking about here. So we prompt the user, write, enter selling price. So the user enters the selling price. Then we input the selling price. Then after that, write, enter cost price. Then we prompt the user to what? Enter the cost price. When the user enters it, then we input the cost price here. Then after that, we calculate the profit is equal to what? Selling price minus what? Cost price. Then we display what? Profit. So the program ends. So you see that it's a very simple algorithm, very straightforward, precise, no curve, no bend, no nothing, no decision making. So this is written in what? Sequential. So it's in sequence. So after this line of code, this is also executed. This is also executed. There is no decision making at any point in time. But I'll be seeing pseudocode with what? Decision making. There you see how it's also written. So let's go over again. So an algorithm in pseudocode to find the profits on an item bought in a shop. So this is how the algorithm is written. Like I said, every program has starting point and then ending point, right? So does our algorithms. We have to start and then end it, since it is acting just like our programs. So first of all, start. Then we declare our variables. So we say declare selling price, cost price as float. And I explain why we are declaring them as float and not integers. So you write, after that, we prompt the user to enter the selling price. When the user enters it, then we input it. Prompt the user to enter the cost price, then we input the cost price. Then we go ahead and take the selling price and cost price and then process it here by subtracting cost price from the selling price. Then we display the profit for the user to what? See. So that is the algorithm written in what? Pseudocode. So that is that. If you say write an algorithm in pseudocode, this is how it looks like. Example 2. Say write an algorithm in pseudocode to find the area and perimeter of a rectangle. So you can pause this video at this point in time. Then try writing it by yourself. After that, you compare your answer to that of ours here. So I'm waiting for you. I'm sure you are done now. So proceed and check your answer and compare. So this is the solution. It's an algorithm in pseudocode to find the area and perimeter of a rectangle. First, we start. As usual, we write start. So we're going to declare width and length as what? Float. Because in dealing with width and length, can be floating point numbers. Because length can be what? 2.5. It can be what? 2. It can be 3.9. Width as well can also be like that. So to be at the safer side, we declare them as what? Floats. Because they can be floating point numbers. So after that, so the program knows that we have two variables input to take, and we've declared variables for that. We learned that before we use variables, we have to declare them. So since we shall be using length and then what do you call it? Width, we are declaring them as what? Floats. And then we are declaring the variables there. So that is what we are doing. The first step says start. Second step says declare width, length as what? Float. We talk of combining two variables and then declaring them at once, or data types and then declaring them at once. The data type we are taking here for width and length is what? Float. So since they are the same, we take them and then declare them at once. So that is that. So the third line, we prompt the user to what? Enter the width of the rectangle. So you and I know that to find the area and perimeter of a rectangle, we need the width and length, right? So you enter the width, then we input the width. After that, right, enter the length of the rectangle, then we input the length. Then we go ahead and take the length and width you have entered. Then we say perimeter is equal to what? 2 times what? 2 into bracket, the sum of what? Length and width. Then we go ahead and take the same length and width to calculate the area. We say area is equal to what? Length times what? Width. Then we display the perimeter, then we display the area, then we end the program. So after all this, after you entering your length and width, leave the rest for the program to get executed. It will come and process here, and then it will keep the results, process here, keep the results, and then it will go ahead and display the perimeter and display the area for the user to see. So a very nice program here, written in what? Pseudocode. So you can equally prompt your student in the class after learning the concept of pseudocode, importance of it, the do's and don'ts of it. You can give them another exercise. You should write a program in pseudocode. By then you should have understood what programs are and how they are written. They might have understood what algorithm is. So in fact, let's try and let them understand all this. Let them get involved in this. And you see the powerful programmers among them. Some of them are very powerful. Just that the opportunity is not there and they don't know what is going on. So it is time for us to let them know what is going on. The breeze of what change is blowing. Let's embrace it. Let's embrace it. Let them feel it. So let's explain to them the concept of what? Pseudocode. Very soon we'll look at flowcharts where they will have to draw. You know, they like drawing. They will love it so much. That is that. So example 3. So we have another example here. Write an algorithm in pseudocode to find the age of a user. So you can equally pause this video here. Write the algorithm in pseudocode. Then after that, you do what? You resume the video again. Then you compare your answer to that of ours. Let me give you a tip. Don't forget to start and end your program. Because normally when writing algorithm, we do forget of the starting and end, forgetting that the pseudocode is just like the program. So that is how it is. So I'm waiting. Right. I'm sure you are done now. So let's check and compare our answers. So solution 3. An algorithm in pseudocode to find the age of a user. First of all, we have to start the program. Then we have 2 variables to declare. Because we are going to take the current year and then the birth year. Because that is what we are going to be using to what? Find or calculate the age of the user. So this is another simple and nice program. So it's a start. Declare current year and birth year as integers. Why am I declaring birth year and current year as integers? So who can tell? Just tell me. Just say it. Just tell yourself the answer. Say the answer to yourself. You know why? Because year, birth year, and current year, which are all years, can't be in what? Floats, because there wouldn't be decimal points in them. Year like 2020, is there a decimal place in it? No. Year like 2025, is there a decimal place in it? 1975, is there a decimal place in it? So automatically we know that they are integers. They are no floating point numbers. So we declare them as what? Integers. So after that, we've declared our variables. So we can now begin prompting the user to enter them. So right, enter the current year. So you enter the current year. Then we go ahead and input the current year. Then we input it. We go ahead, write, enter birth year. Then we enter birth year. Then we input the birth year again. After that, we take these 2 inputs and make decision and then process it here. So the age is equal to what? Current year minus what? Birth year. So birth year will be that you've entered will be subtracted from the current year you've entered. Then after that, it will display the results will be stored in this variable called age. So you say display age means display the answer. So whatever answer you get will be stored in this. So when we call display age, the answer will be displayed, and then you see the answer. If you are 25 years, to display 25. So that is that. And then the program ends. Another very simple and sweet program or algorithm written in pseudocode. So you can go over again, wherever there is any question, you prompt us and then we go ahead and answer. So another example, we are giving all these examples to make us understand what pseudocode is and how it is written. So write an algorithm in pseudocode. This in pseudocode, right? So forget about. Let me see. Let me confirm. Yeah, it's in pseudocode. So it's just a typographical error here. So let's forget of this. Write an algorithm in pseudocode to take score as an input from a user and display remarks for each score. For example, after students have finished writing the examination, you compile their marks. Each and every student know their mark, right? You want to enter the mark in a simple program, and then when you enter the score, each and everyone know their score, sorry. You want to take the score. So you write a simple program, you take the score, you input the score. When you input the score, you hit enter, then it will give the remark for that score. So you see that it's a very nice program. So you can pause it. Imagine how the program will look like. Don't forget it's going to be written in pseudocode, so it shouldn't be any problem because we've seen series of examples. So pause the video here, go ahead and write it by yourself. When you are done, resume the video and compare your answer. I'm waiting. All right, I'm sure you are done now. Let's compare our answers. Say an algorithm in pseudocode to take score as an input from a user and display remarks for each score. First thing first, we start. So we declare score as what? Float. We are declaring score as float because you can get 55.9, 55.5. So it's a floating point number. You can equally get 55. It's an integer. But to be at the safer side, since we can equally get what? Float in our scores, let's just declare it as what? Float, to be at the safer side. So you write enter score. So we prompt the user to enter the score they get. So when they enter the score, good. Here we are going to make decision. Like this. So here there is a decision making here. So what is the decision here? So we want to decide because we don't know the score each and every user has. I like this program. Please, let's take note of this. The other program, there is no decision making anywhere. So they are just in sequence. So this is what conditional or decision or selection type of program. We talk of the categories, right? So this is one of the typical example of what decision or selection type of program. So let's analyze it very well. Let's digest it. Now, say, write a program algorithm in pseudocode to take a score as an input from a user and display remarks for each score. So, for example, if the user gets 90, so one day the program to display excellent. If you get 80, display excellent. If you get 50, display very good and all that. So typically, that is what I'm talking about. So let's see how the program goes. So we declare score as float. I've already explained that. Right, enter score, so we input the score. So here we are making decision here because we don't know the score the user is going to enter here. So we have to make provision for that. Wow. So that is one magical thing about computer. Not knowing we are the same people programming it to behave that way. Very soon you'll be programming the computer to also make decision on its own based on the conditions you've given to it. This is so sweet, right? So we say what? If score the user enters equal 7, or we are using what? The OR operator here, so that we can combine multiple options together, so that we don't have to state them line by line. So it's allowed. Or that, but the OR should be written in what? Capital, like this. If score the user gets is equal to what? 7. What it means is that if the user enters a score and the score is equal to 7, or equal to 8, or equal to 9, or equal to 10, then display excellent. So if the user enters 7, 8, 9, or 10, any of them the user enters, it will what? Display what? Excellent. Now, we are making decision here, right? Else if it didn't happen like that, it can be that whatever the user enters is not within this range. So this block of code will be skipped, as I've already explained, because the condition here might not be met. Example, let's say the user enters 5. So let's check on that. Say else if score equal 5 or 6. So if what the user enters is either 5 or 6, then display what? Pass. And else means anything the user enters aside this 5 or 6 or 7 or 8 or 9 or 10, display fail. It means the user has failed. It means anything below 5, that is 4, 3, 2, 1, means you have failed. So it should display what? Fail. I hope you are getting what I'm talking about here. So now let's check this out once again. Let's see the portion of the program that will be skipped at a point in time during the decision making. Let's assume I've started a program. I've entered a score and my score is 4. So you see that this condition is not met. So this block of code will be skipped. Because I've entered 4. This condition, this block will also be skipped because the condition here is not met because the number I've entered is not within this range. So it will just jump and come here straight forward and display what? 4, because what I've entered falls under this rate. Else means anything lower than what? 5. Display fail. And 4 is what? Less than 5. It's below 5. So I failed. If what I've entered here is 6, you see that this line of block will be skipped because what I've entered is not within this range. So I wouldn't get excellent. So it will skip the excellent and come and check here and check and realize that, oh, I have 6 here. So let me execute this block, then it will execute this one and display pass and tell me because I've gotten 6, I've passed. So you see how sweet the program is? So that is how it is. So this is one typical example of what selection or decision-making program. It makes a decision in a very nice way. So we are going to be writing all these algorithms we are writing here in pseudocode, as well as those we're going to be writing in flowchart. We're going to implement them in Python. You see the power of Python. So let's be anticipating all that. So let's proceed. Now we are back again to another what do you call it? Program topic. That is what a flowchart. Now, what is a flowchart? So now we are done with what pseudocode, and we know what pseudocodes are and how to write pseudocodes, the do's and don'ts, the advantages of pseudocode and all that. So we understood that, right? I pray you should be able to explain the concepts more than I've just done to your students. I mean, good. So this is a diagram that uses special symbols to display pictorially the flow of execution within a program, just as you saw in pseudocode, which is written in English language. This one, there are some symbols we are going to be using, and we are going to be writing the text we wrote in pseudocode inside these symbols. And each and every symbol in flowchart has its intended use or purpose. So we'll see that. So this is a diagram. It's called diagram because it involves connections of what? Various symbols to form a diagram. That is the special symbols that I'm talking about to display pictorially the flow of execution within a program or a program module. So it is a formalized graphic representation of a program's logic sequence, a work or manufacturing process, or any similar structure. It is just the way we use diagrams to represent our program or our pseudocode. That is what we are talking about here. Forget about the plain English. It provides an easy, clear way to see which piece of code flow the various programming structures that all programs are constructed from. So with the nature of the diagram, you'll be able to see that from this level, this is where I'll be going. After this is where I'll be going. And each and every symbol tells or decides what has its intended use. Let's see what is going to happen here. So in creating a flowchart, so a programmer will create a flowchart to aid in understanding the flow of a program, just as you saw in pseudocode. The pseudocode explains the flow of a program. The same thing applies to what? The flowchart. The only difference between pseudocode and flowchart is that pseudocode is written in just normal English plain text. But the flowcharts, we have the diagrams, and these texts are entered in the various diagrams. But based on the symbols of each and every diagram, that is what is entered into it. We'll see all that. So then the programmer will write code in a specific programming language after specifying your program. So someone can specify their algorithms in pseudocode. Another programmer can decide to specify their algorithm in flowchart. Another can just go ahead and leave flowchart and leave pseudocode and go straight forward to what? Implement it in a programming language. Let me use myself as an example. I never knew of flowchart and pseudocode or blah blah algorithms or whatever. I just went ahead and started learning Python. I had interest in Python, then I was learning it. So I even installed the app on phone. So I write Python codes even on bed. I do that. I have it on phone. So I write it always. And I just like how programs work. I try to understand. I never knew flowchart and pseudocode until we've been to the university, that is UCC, for our program. And it's part of the course outline. So at least we have to cover up all that. So after understanding what flowchart and pseudocode is, the love for programming has now graduated to another level, my brother. So that is that. A programmer can decide after writing the algorithm, let me specify it and see how it will flow. So I'll use pseudocode to do that before I can then what? Use programming language to write it. Then I'll make it executable for users to use my program. Another person can say, oh no, I don't have to use pseudocode. Let me go for flowchart. I'll use flowchart to what? Specify my algorithm, and I'll see the flow of the program, after which I'll then use a particular programming language that I'm good at to implement it there, make it executable for users to use. Another person can decide, I don't need flowchart or pseudocode. Let me just implement or write my algorithms in programming language, so the person just write it and then straightforward. So that is what I was doing. I started using the programming language at once, but now I've come to understand that with the pseudocode and flowcharts, you'll be able to understand the flow of a program. So even when we're doing the training, anytime I write programs in pseudocode, I try to implement them in the Python language to confirm the flow of my program. If there's an error or there's an issue, it means there is no logic in my program. So I'll see the error in Python and correct it. So basically, that is that. Now, the interactive flowcharting applications are available for creating flowchart. We have programs that we can use to create our flowchart on the computer. We have a program called Raptor. We can use it to create our flowchart. MS Word template as well. You have the shapes. You can just drag the shapes, join them, and then you create your flowchart. So let's see. Flowchart symbols. So a typical flowchart will include some or all of the following symbols. We have the start and end symbols. So just as you saw in pseudocode, in flowchart as well, we also have start and end. Just as I've already stated, all what you saw in pseudocode, the same thing happens in flowchart. The only difference is that in flowchart, the diagrams are representing this, what do you call it? The steps here, where you have to declare your variables. The diagram for that is there. Or you have to start, the diagram for that is there. Or you have to make decision, the diagram is there. You have to take input, the diagram is there. Or the symbol is there. You have to display output, the symbol is there. So that is the difference. So you write all these symbols, join them together, then you put your text inside. So that's all. So we have the start and end symbols. So the start and end symbols are represented as oval. So the oval symbol or the rounded rectangles are used to represent the start and end. Arrows show the flow of control. And after writing your start, then we have an arrow joining the start to the next symbol. So it shows the flow of control. An arrow coming from one symbol and ending at another symbol represents that control passes to the symbol to which the arrow points. So if you see an arrow and then the point of the arrow tells you that from this I'll be proceeding to this, from here I'm going to this. It just shows you the flow of the program. That is it. Now we come to the processing steps. These are represented as what? Rectangles, where we process something. Example, calculate something. Calculate the sum. So where the processing takes place, we use what? Rectangle to represent that. Now the input and output, where we have to take input and then display something for the user to see. We use the parallelograms symbol to represent that. Now when we have to make a decision that is conditional, we use segments are represented in a diamond shapes. The diamond shapes are used to represent condition or decision-making stage. These typically contain yes, no question, or true or false test. These symbols has two arrows coming out of it, where we have to make decision. So based on the decision you are going to make, we have two arrows coming from the diamond symbol. If based on the decision, if it is true, you have one arrow coming from one side. If it is false, another arrow coming from one side. And where the arrows are heading towards and what they'll be doing, we'll be seeing that in a couple of minutes. Now we have the connectors. So connectors are represented as circles. So we use the circles as connectors. So these are used to connect one program segment to another. So that is that. Now these are the symbols we have here. These are the symbols, the name of the symbols, and then the description. We have the oval. The name is what? Terminator. Represents the start and end of the program or module. So if you want to start at the beginning of the program, we use this and then we end with it again. So start and end. Process, where you have to maybe process something. We can equally use this to declare variables. So we don't have it here, but declaration of variables is a process, right? So that's what we are talking about here. So we can equally use this to represent process, where you have to calculate something, calculate sum, calculate profits, compute area, and all that. So process, this is what happens there. So this is the name process. Represent any kind of processing function, for example, a computation, where you have to compute something and then give output or results. You have the input and output, where we have to take input. You saw in pseudocode where we take input and then whatever. So we use this symbol to represent input and then output. It's a represent an input or output of operation. And we have the decision. We have this diamond symbol for decision making. Represent a program branch point. So when you get there, you have to make decision. If the decision is true, you decide to pass here. If it is false, you pass here, or the vice versa. Anywhere at all you want to pass, you do. And we have the connector, which is a circle to indicate an entry or to exit from the program. So that is that. Now let's look at the example of this is a pseudocode, and this is how it's represented in a flowchart. So consider the pseudocode below. So start, display welcome message, input data, calculate age, output results, end. Now you and I know the symbol for start, right? So let me assume that this particular flowchart is not here. So after you going through these symbols, their names and then their description, that is what they do. And you've come to see this. Then I'll ask you to write a flowchart for this particular pseudocode. This is how it should be. Start, we talk of this symbol as the starting point. So introduce that to your student, let them know that this is the starting point of the program, and this symbol is used to represent that in what? Flowchart. Then after that, display welcome message. To display something is what? Output. And we talk of output and input being the same, right? So output and input represent what? This. We use this to represent that. So that is what we are seeing there. Display welcome message means what? Show something for the user to see, which becomes what? Output. So we use the output symbol. Input data. So it becomes input. So we use the input symbol. So output and input symbols are the same. Calculate average is a process. So where you have to take some numbers here, some variables that you declare from here or whatever, and then use them to process something to calculate the average. At that point where the average is being calculated, it's a process, right? So we use the rectangle to what? Represent that. Then the output, where we have to maybe display the results, we use the output symbol. Then after that, the program ends. So this is a very simple program for maybe calculating age, where you have to take average, where you have to take two numbers or more than two numbers or whatever numbers you have to take. Then after that, you go ahead and calculate. So basically, this is a pseudocode, and this is the flowchart for the pseudocode here. So you can equally go back to the previous pseudocodes we wrote and try to represent them in what? Flowchart. But we have a series of examples to check on as we proceed. So let's go ahead and look at that. You can equally pause the video here and go over again. The start is here. Display welcome message, we use the output symbol. Input data, we use the data symbol. Then calculate average, then we use the process symbol. Then output, we use that, and then end. You can see that there are arrows joining. There's an arrow here joining here, another arrow here joining here, another arrow here joining here, another arrow here in that order. That shows the flow of what? Control in the program. So basically, that is that. We have another example. You saw how the previous flowchart was written. It doesn't mean it's always like this. It can be written horizontally, it can be written vertically or wherever. It can be written in stylish. It's just the arrows that you have to direct well to show the flow of the program. That is what matters. Sorry, a minute. So basically, that is that. Now, let's proceed. So this particular program here is used to calculate the area, the circle area program, the area of a circle, right? So we have the start. We input the circle radius. We need the radius to be able to calculate the area of a circle, right? So we compute circle area using the circle area formula. So you know the formula. So you do that and then you display the results. So at the starting point, and then after displaying the results, you end your program. So after the starting point, we use the starting symbol in flowchart to represent that. So we are writing this. This is the pseudocode, and this is the flowchart of it. So after writing this, so this is the symbol for it. Then you write the oval. Then you write start inside. Then 2, input the circle radius. So you use the input symbol, and you write input circle radius. Then 3, compute circle area using what? The circle area formula. So you write that there using the process. So at that moment where the circle area is being computed or is being calculated or is being processed, becomes what? The processing stage. So you use the rectangle for that. And when you are done, you have to display the results for the user to see, right? So use the output symbol. So after displaying the results, the program has nothing to do again but to end. So you end it here. So we use one of the terminators. So the end here, use the end symbol and write inside end. So you can equally redraw this one in a vertical manner. Is the same thing. So it is only the arrows that matters. The flow, because it shows the flow of control of the program. So that is that. Here's also another typical example of a flowchart. It's a very simple one. This one involves decision making. I like this one. So it's like this is the starting point of the program. So we enter from here. We start. Say, is it raining? If no, then go to the park. And then after going to the park, the program should end. Maybe there's a program that should check if it is raining, then something must happen. If it's not raining, another thing should happen, right? So a very simple and nice program written in Flowchart. So this is how it's written. You can see how this one is also written. So depending upon if you can write it the way you want, you can design it the way you want, but it's the arrows that matter, the flow of the arrows you can see. So be able to follow the arrows and know the flow of the program. So from the starting point, we come to what? Decision making. So we can say what? Is it raining? So we are making decision here. If no, we have to do something. Then what do? We go ahead and go to the park because it's not raining, so we go to the park. After going to the park, the program ends. That is that. If yes, then we follow this way and go to the movies. After going to the movies, then the program ends. So with this arrow here, we can equally join it from here as well and bring it this way and then display what do you call it? Go to movies. So this go to movies is what? It's a process. Going to park is a process. So the process symbol is used here. Then after that, proceed from here and end. Every program has a starting point and an end point. So this is another simple example of what? Flow chart. And this type is for decision making. And you see how it's written. So for example, I can say, write a simple program to tell if the number that the user enters is greater than 5. If it is greater than 5, tell the user that the number is greater than 5. Please write this question down and then try it by yourself. Are you ready? Let's go. Write a simple program that take number as input. So if the number is greater than 5, the program should display that the number is what? Greater than 5. If the number is less than 5, the program should display that the number is what? Less than 5. So that is that. Write it in pseudocode and go ahead and write it in Flowchart. So let me just try explaining something here. So with this particular question, you go ahead and then go with after writing it in pseudocode. So you write start. You have to declare the number. What are you declaring it for? What data type are you taking? It's going to be a float, right? Or an integer, whatever. So you decide. So you take. Then after that, you prompt the user to enter the number. After the user enters the number, then you make decision. If the number is what? Greater than what? 5, then something must happen, right? You tell the user, display the number is greater than 5. Else, display the number is what? Less than what? 5. So that is after writing that, you implement that in Flowchart. So you do that. So you know that in Flowchart too, we have decision to make. So at this point, when the user enters the number here, then we ask ourselves, is the number greater than 5? If it's greater than 5, we go ahead and say what? The number is greater than 5. If no, it means it's what? Less than 5. So we go ahead and say what? The number is what? Less than 5. So if it's greater than 5, we say yes. So you can see that it's not always that no start from here and then yes start from anywhere. So it depending upon what you want it to pass from or to lead to, it doesn't matter. So I'm deciding that. You can see that here we have no here and yes here. But in my program, I'm going to be keeping the yes here or whatever. So I will say, is the number greater than 5? If it's greater than 5, then yes. Follow and display here for me. The number is what? Greater than 5. If no, then I'll write here no. Display and say the number is what? Less than what? 5. And then exit. Here to exit the program. So try that by yourself. This is another example. So we start with a flowchart. Like I said, declaration of variables is a process, right? So this is what is going on here. We are declaring a variable using a very long rectangle. So it's the same thing. So declare variables, length, width, and area. And here we are to input something. So you input what? Length as L, and then you enter width as W. So you do that. So we use the input symbol. And after that, we follow the arrow flows. Then we go ahead and calculate the area here. So we are using the process symbol. When we are calculating, we are computing, or whatever we do, it's a process. So we use the process symbol to do that. And after that, we display the results. Then we end the program here. So write this simple program in a pseudocode. This is written in Flowchart. Write it in a pseudocode. Please, when writing your programs in Flowchart or pseudocode, to make our work easier for us, since we shall be writing and sketching and writing all this on the marker boards and then blackboards in our various classes for our students or for our pupils, just take a piece of paper, write the steps, and then take a shot of it, picture of it, and send to me. Or if you like, you can write the steps on your phone and then you send it to me. But with the flowchart, please just draw it on a sheet of paper. Don't try using Word. It will delay your time, please. It delays time. It makes it boring. Just take a piece of paper and a pen, very nice piece of paper, of course. Then you draw the flow chart on a piece of paper. Then you do the necessary entering of whatever it is. And after I take a picture of it and then you send it to me, write your name on it, and I'll see that you are the one. And we access that and then try to evaluate just to build our confidence, and that's all. So let's proceed. So we have another example here. Write an algorithm in Flowchart to take score as an input from a user and display remarks for each score. So let's check. Good. Here we go. So here, let's read the question again. Write an algorithm in Flowchart to take score as an input from a user and display remarks for each score. We've already written something like that in pseudocode. So we are going to write it in Flowchart now. So we are declaring the score as what? Float, because we stated that a score can be what? 7.5, 95.5. The moment points come in, it means it's float. So we are doing that here. Then after that, after declaring our score, we start and then we declare our score. After declaring our score, then we ask the user to what? Input the score. Now, the user input the score at this level. Depending upon the score the user input, so we make decision based on the score the user enters. So we are making decision here. Is score equal to any of this? The score the user input from here, is it any of this number? Is it 7, 8, 9, or 10? If yes, write pass. If no, then skip this. Don't come here at all, because the number you input here is not in this category. So it means it's no, right? So you come and check it. The program flows this level and come and check here. Is score equal to 6? Depending upon what the user inputs here. If the score is either 6 or 5, it will then go ahead and say yes. Then it will write what? Retest. That is what I've decided to write. Don't worry about what is written here. Retest, right? So it should display something like that. But if the score you've entered is not either 5 or 6, then it means it's below 5. And for that matter, it's no. So you go ahead and write what? Fail. And after that, every program has end, right? So you take it from here, come here, take this from here, come here, then you take this from here and come and end your program here. Let me go over again. It's a very nice program. Say what? Start. Every program has a starting point. And we declare our variable. So declare score as what? Float. So we are declaring score here as float because I'm saying it again that scores can have points or floating point numbers in them. So to be at the safer side, we declare them as what? Float. Then after that, we go ahead, then we prompt the user to what? Input the score. So we use the input symbol. For the first time, all these things will look new to you. But as time goes on, you begin writing your pseudocode, implement your algorithm in pseudocode and flowchart. My brother, you like it. Yes, you like it. So we prompt the user using the input symbol. So input score. So you input the score here. Since we don't know the score the user is going to input, so after the user inputs it, so we take it and then make decisions here. The first decision, we ask ourselves, what does the user put here? Does it fall between this? Is the score equal to either 7, 8, 9, or 10? If yes, oh my brother, let's write pass. So the program should flow straight forward and write pass. So you see that all this is ignored now. So after writing pass, it will follow this way and come and end. So the program ends because it has gotten what it's looking for here. But then, if the number the user input is not in this category, the program will not come here again. It will skip all this. It will not end. And it will come here and check now what the user has input. Is it 5 or 6? If it is none of this number, then what it will do is this. If the number doesn't fall here and it doesn't fall here too, then it will not. If it is either 5 or 6, it will say yes. Or what the user has input is what? Yes. So I'll go ahead and say what? Write retest and display that because where the user has entered is either 5 or 6, so I'll write retest. But if it is no, it means what the user has input is not 5 or it's not 6, and it's not in any of this category, it's not in any of this category too. So it means that it is something below what? 5. So for that matter, what do we do? So we go ahead and say no. Then we write what? Fail. Then from there we proceed and then end the program. If what the user enters falls within this range, so we go ahead and say yes, and then we write this, and then we end the program here. So wherever we pass, we'll be able to end the program. So if we pass here and come this way, start here, and we make decision here, and we decide that no, and we decide that yes, then we execute this, and then we end the program here. If it's no, and then we find ourselves and we make decision, and our answer, what the user enters, is here, then we say, oh yes, then we write this, and then we end the program. If it is no, we flow this way and come and display this word. Fail, and then we follow this way and come and end the program. So very nice and sweet and beautiful program. Written by Sir Bachman, Philly Gadochi. That is my boss. I salute you. So that is that. So another example here is write an algorithm in Flowchart to find profits on an item bought in a shop. So in the Flowchart, we've written it in a pseudocode. So the solution is here. First of all, you know what to do. We start. Then we declare our variables. So the variables here we need are what? Cost price and then selling price. So you and I know that prices or currencies like this should be float, right? Please, let's just take this once and for all. When declaring them, we should know where our stance in the data type they are. So we declare them as they are. So we are declaring cost price, selling price as what? Float. So we declare variables here using the what? The process symbol. Declaration of variables is a process. So after that, we prompt the user to input selling price. So please enter a selling price here. So we are using the input symbol. And after that, we input the cost price. The user enter the cost price, so we input the cost price. After that, we compute. So we are using the process symbol here to compute the profit. So we compute and say, so it's a process. What is going to happen here is a process. So we use a process symbol. Processing is taking place here. So we say compute profit is equal to selling price minus cost price. So display profit. So it will go ahead and we use the display what? Symbol and then display this. So we are good to go. So we display the profit here, and then we end the program here, then we are done. So you can cross-check, edit, cross-check, and then if there is any question, you go ahead and ask. So another one is write an algorithm in Flowchart to find the area and perimeter of a rectangle. So let's check the solution. Is that what? First of all, we have to start the program, right? So we start the program here. Please let your student feel this. Let them feel it. Let them feel it, please. Explain to them the concept. Let them do the drawings. Let them know what variables are. Let them know what the data types are. Let them know what flowchart is. Let them know what pseudocode is. You should have complete and absolute control over the computing curriculum. Our platform is going to be our classroom. So this platform we are using here is going to last forever. We're going to be learning a lot on this platform, sharing ideas in this platform. In some few years to come, we want to get developers and then software developers from our platform. Amen. So that is that. So first of all, we declare our variables. So we declare, so to find let's see the question again. To find area and perimeter, we need what? Length and width, right? So declare W, I'm just shortening it. It's also allowed. W as width and then L as what? Length. So we're declaring them as float. So we prompt the user input width. So the user inputs width. And from there we take it, then we input length, the user input length, then we go ahead and process. So you see that we are using the input symbols here, so don't forget of that. We go ahead and process it here. Then we compute what? Perimeter is equal to what? 2 multiplied by the sum of what? Length and width. And then we do that here and then store the answer. And we process the area here as well. We compute and then you do whatever and store the answer. Then we display them. So you see that inputs, taking in the input and displaying output are using the same symbol. So we display the perimeter, we display the area. Display P meaning display perimeter, display A meaning display area, and then you end the program. So that is that for this one. Example 3 is write an algorithm in Flowchart to find the age of a user. So solution 3 is start. As usual, we start. Declare current year. So to be able to do that, we need the current year and then the birth year of the user. So we want to declare current year and birth year as integers because there is no floating point number in what? A year. So they are just the way they are. So we declare them as integers. So we say input current year. CY means current year. So the user does that. You input current year. The way you declare that, wherever you call it, the computer knows that you've already declared it. So if you use it, it knows what you are using. If you go and write current year here in full, and you come and shorten it here, you would understand, but the computer will not understand it. So whatever you declare here, you use that here. If it's in a real programming language, it will even give you error. You can't declare something and be using a different thing. There's no logic in that. So that is logical error, right? You'll be seeing these errors here right away. So that is that. Now we go ahead and then prompt the user to input the current year. The user input the current year. We take the current year. Then we ask the user to what? Inputs the birth year again. Then the user inputs what? The birth year. Then from there, we calculate the age by by what? Subtracting the birth year from what? The current year. So doing that becomes what? The process. So we use the process symbol. Then we display the age. After subtracting, it will store in this variable called age. So when we say display age, it will display the number after this operation here, and then the program ends, and that becomes your age, and then the program ends here. So that is that. Good. So we are done with our example. So we understood what pseudocode and flowcharts are, and how pseudocodes are written, and how flowcharts are also written. We'll be seeing more of them in our subsequent lessons to come. So let's hope and anticipate for them as they come. Now let's look at types of programming errors. Errors are common when writing programs. If a test run turns up problems with the program, you must debug it. Well, what we are talking about here is that when we are running the program and there is an error, we have to debug, which means we must locate and eliminate the error. That's what we are talking about. So the two fundamental types of errors that can arise in coding a program are syntax errors and then logic errors. Normally, even on our computers, we do see this syntax error. Very soon we'll see how or what it is. What at all is the calculator talking about? Syntax error and then those. Let's see. Syntax error. A syntax error is a violation of the programming language's rules for creating value statement. Not knowing the calculator has been programmed in a way. So if you enter the syntax violating the rules the calculator has been programmed to what? Give output for, it will tell you syntax error. So don't forget, whenever you see syntax error, you are violating some rules, right? So you've got to know of this from today. It can be caused, for example, by misspelling keywords, but let's come to programming world, right? A syntax error is a violation of the programming language's rules for creating valid statements. Let's take Python, our friend, for instance. The big snake that can thrive anywhere, can enter anywhere. I love Python. Now, it can be caused, for example, by misspelling a keyword or by omitting a required punctuation mark. For example, after writing a statement like, if so and so is this, you have to terminate it before you bring the block of code that should be executed. And we use the, semicolon to terminate the statement. If you fail to terminate the statement, you get syntax error. You violated the rule, so that is that. Syntax errors are detected by the language software. Yes. So even the syntax errors can be detected by the text editors we'll be using. In our case, we shall be using what? PyCharm. At the point in time, I decide to even use Sublime Text. All this can detect what? Syntax error. So syntax errors are detected by the language software, either when the invalid statement is typed or when the program is what? Translated by the computer into what? Machine language. When we are running the program for it to be translated and there is an error in it, the text editor will display the error and you see it at the bottom. We'll be seeing that in Python very soon. So when the software detects a syntax error, normally it issues a message and highlight the offending statement. Therefore, syntax errors are often easy to find and correct. Very good. It's true. In Python, when you write a program and then you run it and there is an error, it displays it at the console. So you'll be able to see the line. It will tell you that on line 1, you failed to do this. You even see an arrow pointing at that. If you know what the error is, you go ahead and fix it, and when you run the program, it should run successfully without any issue. So basically, that is that. Now let's see what logic errors are. See, a logic error results from A logic errors result from failing to use the proper combination of what? Statement to accomplish a certain task. Maybe if you fail to combine combination of what? Statement to accomplish a particular task. Maybe you can write a program which doesn't make logic. For example, how can you declare a variable? I was just giving an example there. You declare a variable, current year, and then birth year. You write them in full. You declare them as what? Integers. Then when in the course of writing your program, then when calling the current year and birth year, which you've written in full, you decide to shorten it there. That is logic error. It doesn't make, there is no logic in that. Okay, so that is another example of what? A logic error. It may occur due to faulty analysis or faulty design or failure to code a program properly, and that is what I'm talking about. Logic errors often cause the program to fail to proceed beyond a certain point. So with this, your program will not even proceed. It will crash or hang or freeze. And sometimes it even gives incorrect results. So that is what happens. These are some of the disadvantages of what? Logic errors. So unlike syntax errors, logic errors are not detected by the programming language software. It is true. That is, with the logic, it is your logic, and it's the program logic, right? What you are writing, even when writing a program in pseudocode and flowchart, after writing it, ask yourself, is there logic in the program? Yes, you are a programmer, right? This is the beginning. When you begin writing, after writing it, you test it, or you give it to someone, and the person try to challenge you and ask you some questions which you can't even answer. It means your logic might not work, or maybe it's not working. So there is no logic in your program. So with that one, the programming language doesn't detect that. So you should be able to detect that and fix that by yourself. You can't use almighty formula in finding area of a rectangle, right? It doesn't make logic. There is no logic in that. It means you're using the wrong formula to find something. You might end up getting a different answer. So and there's no logic. And that is not the answer you are even looking for. So that is how logic errors work. The following are a few kinds of logic errors. So use of an incorrect formula to produce a desired result, like I'm talking about. Use a different formula, you surely get the results, but still there is no logic in it. Just as we talk of hierarchy of operation, where we talk of dealing with what is in the parentheses, which we call brackets, and we go to exponentiation, then we go to is it modulus? Yeah, modulus. Then we go to division. Then we go to addition and subtraction, right? Basically, that is that. PEMDAS for short. Instead of you starting with what is in the parentheses, you go and start with addition. You surely get the answer. But is that the answer you are looking for? So that is one kind of logic error. You've gotten the answer, but there is no logic in it. The use of an incorrect sequence of statement to carry out an algorithm. Use a different statement to carry out an algorithm. Write a statement which you think is understandable to you, but to another person, it's not understandable. So there is no logic in it. Failure to predict some input data. That may lead to an illegal operation such as division by zero. You can't divide a number by zero, right? How can 0% divide an item? There's no logic in it. When a program is run, this kind of bug is sometimes called runtime error. When you run it, the program, during the running, it debugs it and then tells you that the number is not divisible by zero. So it is called what? Runtime error. You will see that in Python when we get there. Now, this brings us to the end of the lesson. We have some things to try by ourselves. So, in summary, we talked of algorithms, which we've already spoken about in a previous lesson. And we said there are sequence of instructions or steps you write, which we use to solve a particular problem. And we also stated very clear that after writing an algorithm, you can implement it or specify it in the following. That is what? Either in pseudocode, flowchart, or programming language. And we also talk of different categories of statements in programming, where we talk of sequential, decision, and then iterative and loop. With the sequential, we say the statement are in sequence. There is no curve, no bend anywhere. Example, input your name, input your age, display I'm 7 years old. So straightforward. There is no curve, no bend. That is what? Sequential. Now you come to what? Decision. We say what? A typical example, with the decision, at a point in time, you have to stop. The program stops and make decision based on your input or the input it takes. For example, a simple program to find out whether I'm a male or female by gender. So enter your name. So you enter the name. Enter your gender. Then you enter either you are a boy or a girl. So you write. If you are a boy, you write boy. If you are a girl, write boy. Then we take it and we make a decision. By then we should have declared a variable which stores a boy or a girl in it. So we say if what you enter there, the input we take from you is a boy or equal to boy, the program should what? Display and say you are a male. Else you are a female. So this is what? A typical example of what? Decision or selection structure. So at a point in time in decision and selection structure, a block of code is executed when its condition is met. If I input a boy, the program will go ahead and execute the first line of code and tell me I'm a boy. If I input a girl, it will skip that one and come to the second one and tell me I'm a female. So that is what the decision structure. We talk of iterative, that is a loop, which allows us to repeat a process some number of times, depending upon the condition. If the condition is met, we jump out of the loop, program ends there. Typical example is I talk of in writing games. Normally, I always see that when games are written or games programs, you are given some number of lives. For example, I say a guessing game. Guess a word, and I'll give you some number of times to guess. If you get a first time and the word is not correct, I'll check and compare it to the word I call a secret word. If it is not, then I'll give you another chance to what? Enter another word. This process is known as what? Iteration or loop. So we loop for some number of times until the condition is met. So that is that. And finally, we talk of the concept of what? Pseudocode. Where we say pseudocode is what? It's just like a normal English-like statement which we use to what? Implement our algorithm. And we saw how pseudocodes are written. They are written what? Just sequential, step by step. We start with what? Start, and then we end with what? The end keywords. Just like, and we said pseudocode are just like our program. They show the flow of the program. And we say every program has what? Starting point and ending point. And that is the reason why we normally specify the starting point and ending point in our pseudocodes. And we talk of what? Do's and don'ts. And we said when writing pseudocode, it should be what? Specific. There shouldn't be ambiguity. Every statement should be in a line. So you can go ahead and read about this. I'm just trying to get them off head, what we just talked about. And then we proceeded and see series of examples of how we can implement our algorithms in pseudocodes. And we all saw that. We proceeded and talk of what? Flowchart. When we said flowchart is also a way of what? Specifying your algorithm in flowchart. It's one way of specifying your algorithm. So in flowchart, unlike pseudocode, which is about statement written in lines and then numbered, in flowchart we use symbols, and each and every stage has its symbol. And we talk of what? The starting and then the ending, where we say it uses the oval symbol. And we talk of declaration of variable. That is, if your program, there's a point in there you have to declare a variable, we use the rectangle. Input and output use what? The parallelogram. Process, where you want to compute something, you want to add, or maybe sum of something, and then compute something. We use the rectangle. And we use the arrows to join to show the flow of the program. So that is what we talk about. And finally, we ended with what? Syntax errors, and then logic errors. And we said syntax errors, normally when you violate the rules of the language. And we also stated that languages, the text editors or the software or the program language detect these errors, and then they help you to fix them. With the logic errors, with those ones, the program doesn't detect. You have to detect them and then fix them by yourself because it is your logic. So I think this is just the summary of what we talked about. I advise you to go over again and then try. If there is any question, you put, and we see how we can address that. Let's try the following. Design an algorithm both in pseudocode and flowchart for the following. 1, to find the birth year of a user. So you write it in pseudocode and then you write it in flowchart. 2, to calculate the circumference of a circle, both pseudocode and flowchart. 3, to find a sum and product of what? 2 numbers. Same thing, flowchart and pseudocode. Another trial. Design an algorithm both in pseudocode and flowchart to quarantine a person from China. For example, the program should take a person's name. You write a program, you take a person's name. So you have to declare the data type the person's name is. A tip here. The data type for a person's name is a string because it's a collection of what? Text. We say collection of text is what we term as what? A string. And a country. Country too is a what? A string. So we can just combine them and declare them together as what? Strings. So we take them as input. The program should then make a decision. That is, if the person is from China, so you know what decision making is, we talk about that. If, where we use the if and then else if and all that. If the person is from China, the program should display, hey, you are quarantined. But if the person is from any other country, aside China, the program should display and say, congratulations, you are free to go. It's a very nice program. Please do it your own way. It's your logic. It's your thinking. It is how you want the program to be. After presentation and we get to see that there is a problem somewhere, we fix it, and then you learn from that. That is how we learn. Don't wait for someone to finish his and post it. Then you go ahead and look at that one and then try to do that. Think by yourself. Don't look at anybody's work. Do it by yourself. In the process of doing it, you become the boss or the master of it. I think this brings us to the end of this lesson. And I pray to God that all what we've learned in this lesson should be able to remember it and be able to deliver when there is the need. Thank you very much for watching. Until the next lesson again, say bye for now. Stay blessed.